So this is an assignment related to Group 2 and Group 7. And as I mentioned, the Unit 3, most of the questions based on this topic, which is about observations and conclusions. So we'll start with question 23. In question 23, the electronegativities of 4 pair of elements are given below. Which pair would form a compound with the greatest ionic character? So to form the compound with the greatest ionic character means there should be a greater difference in the electronegativity. Means higher or a greater difference in the electronegativity, what will happen? It will be a complete transfer of electron. As a result, it will have a greatest ionic character. So when we check the options, what is the difference? 0.7 and 4. So 4 minus 0.7, that's equal to 3.3, the difference in electronegativity. When we check 0.7 and 3.5, the difference will come out as 2.8. You can also use a chat to state the answer. 4 minus 1, so that's equal to 3.0, and 2.8 minus 0.8, that's equal to 2.0. So highest difference in electronegativity, that's for A. So A is the right answer for this. Question 24. Which of the following statement about elements in group 7 is incorrect? So which of the statement is incorrect? They all show variable oxidation states in their compound. They are not, all of them are not showing variable oxidation state. Like example, for especially for chlorine you will find the oxidation number, the common oxidation number, fluorine, bromine and iodine, it is -1. Few compounds are there in which they may have a different oxidation state, but not like they all show variable oxidation state in the compound. That's incorrect because fluorine does not show any other than -1. Fluorine is the most electronegative element. It only needs one electron. So for fluorine, it is always -1. Chlorine, it may have a variation, like as we mentioned, from +7 to -1. Bromine also may have a variation from +7 to -1, any number, and same thing for iodine. But especially for fluorine, the electronegative, due to the high electronegativity, greater tendency to attract the electron, it has only tendency to take one electron. That's why oxidation state is always -1, because fluorine cannot have a positive oxidation state as it is the most electronegative element in the periodic table. Like it has a greater tendency to attract the shared pair of electrons. So it is impossible for fluorine to have a positive oxidation state. But chlorine, bromine, and iodine may have a positive oxidation state, depends on what is the other non-metal from which they combine. So option A is incorrect. They all form acidic hydride, like because hydrogen fluoride is there, hydrogen chloride, hydrogen bromide, and a hydrogen iodide. These all are acidic hydrides. That's true. We know A is the right answer. Just I'm reading the other statement, explaining the other statement. The electronegativity decreases as we go down the group. That's true because fluorine is more small in size, more electronegative than chlorine. Chlorine is more electronegative than bromine. Bromine is more electronegative than iodine. So this is also a right statement. And they all exist as a diatomic molecule. That's also true. That fluorine does not exist as a fluoride ion or a fluorine atom. It is fluorine molecule, chlorine molecule, bromine molecule, iodine molecule, acetone molecule. So they all exist as a diatomic molecule. Is it clear? Question 24. The next one, what are the products other than water when a chlorine is passed through a cold dilute sodium hydroxide? You have to memorize this. As we discuss the reactions of halogens with cold sodium hydroxide, NaOH, and with hot sodium hydroxide, the products will be different. So what are the products when we have a cold? So this is the reaction. As you can see, this one, reaction of halogen with cold sodium hydroxide. So when cold sodium hydroxide is bubble uh, through halogen is bubbled through cold sodium hydroxide, this result in a formation of a sodium halide, sodium chlorate, and water is there. So if we have chlorine, it will form NaCl and NaClO. If it is bromine, it will be NaBr and NaBrO other than water. And if it is iodine, it is NaI, NaIO. But if it is a hot sodium hydroxide, then it will be, if it is a chlorine, NaCl and NaClO3. If bromine is there, NaBr, NaBrO3, and if iodine is there, Ki or Ni plus KiO3. But we have a cold, so it will be NaCl plus NaClO. So that's a question itself. That the question is, what are the products other than water when a chlorine is bubbled through cold? So what are the products when we bubble chlorine through cold? So it will be NaCl plus NaClO. And if it was a hot, then it will be NaCl plus NaClO3. But it is a cold one, then this is a product. But what if it was hot? Then this will be the product. The metal salt which give a red color in a flame test is, so the flame color, you have to memorize these flame colors. So barium is there, which is apple green, potassium is there, lilac, sodium is there, yellow. So we have lithium will give us the red color, because this won't make a difference. The element, the metal are responsible for the flame color. So barium will give the apple green, lithium will give red, potassium will give us a lilac color, where sodium will be yellow. In question 27, what is the trend in thermal stability of carbonates and nitrate? Thermal stability for all hydroxides, carbonate, nitrates increases as we go down the group. Like example, because what happened, the substance become more thermally stable. Why it become more thermally stable? Like if you have magnesium carbonate, so magnesium is smaller in size, and then we have a carbonate ion. Then we have a calcium carbonate, calcium is larger in size, and then we have a carbonate ion. So calcium ion, as it is larger, it will cause distortion to carbonate, but small. But magnesium is smaller in size, greater in charge density, cause more distortion, greater distortion to the negative ion. As a result, this will become weak. Carbonate ion will become weak. So when we supply small amount of energy, we can break easily. Here, because less distortion, carbonate ion is relatively stable. As a result, we need more energy. So same thing happen if it was a nitrate. Then same thing will happen. Magnesium cause more distortion, which reduce the strength of a nitrate. So it can decompose easily, but calcium. So whenever carbonates, nitrates, hydroxide, sulfate, whenever we go down the group, the thermal stability for all of them increases. So D should be the right answer. Is it clear? This one about the thermal stability. Which pair of a compound has a more soluble hydroxide and more soluble sulfate? Look, trend in solubility for nitrates and for hydroxides, the solubility increases as we go down, but for sulfate it decreases. Like if we have nitrate, we have hydroxide, and we have sulfates. So it will become more soluble as we go down the group, so solubility increases as we go down. For hydroxides also solubility increase, but for sulfate the solubility decrease as we go down the group. So the which pair is more soluble. When we check the positions in the, we have magnesium in the question, hydroxide and sulfates are there. So we have magnesium hydroxide and we have strontium hydroxide. So as we go down the group, the solubility increases. So which one will be more soluble? Strontium hydroxide should be more soluble. So the solubility of strontium hydroxide should be more. But what about sulfate? For sulfate, the solubility decreases as we go down the group. So strontium sulfate will be less soluble and magnesium sulfate is more soluble. So as we go down, it decreases. So magnesium sulfate more soluble. So which pair? Magnesium sulfate more soluble, where strontium hydroxide more soluble. So option C will be the right answer. The table shows the measurements uncertainty of each reading for some lab apparatus. The item of a laboratory apparatus that would measure 25 cm with the lowest percentage uncertainty. How to work out the percentage uncertainty? The formula for percentage uncertainty. The percentage uncertainty for any apparatus is equals to uncertainty means the smallest value which instrument can record divided by value recorded into 100. But if we are using the apparatus twice, then the uncertainty will be multiplied by 2. Like example, when we are using a burette, so how a burette is used for any experiment? First, we read the initial volume, and then how much we remove, we read the second volume. So because we have to read this apparatus twice, so what happened to uncertainty? The uncertainty will be twice because we have to read it twice. But for a pipette, we just have to read only one mark. We just have to read only one time. That's why its uncertainty is not multiplied by 2. But in case of burette, it is always multiplied by 2. So if a apparatus is used twice, like example, if you are using a thermometer to measure a temperature change, that case the uncertainty will also be multiplied by 2 because we measure the initial temperature, we measure the final, so each value will have uncertainty. So the total uncertainty will be twice of the original uncertainty. So if you are finding the percentage uncertainty for a burette, for a measuring cylinder, for a pipette, and for volumetric flask. So what is the formula? Uncertainty for a burette is 0.05. But that will be multiplied by 2 because burette is always, whenever we read the volume from burette, we have to read initial and final volume. And divided by the value recorded, so how much value we want to record? We want to record 25 into 100. Same thing for a measuring cylinder, uncertainty is half divided by, so uncertainty is half divided by 25 into 100. For a pipette, uncertainty is 0.06 divided by value recorded into 100. And for a volumetric flask, the uncertainty is 0.1 divided by value recorded 25 into 100. So which is will give us the smallest answer, the least percentage uncertainty? Pipette or C will be the right answer. Is it clear, this question 29? In question 30, on adding chlorine to water and aqueous sodium bromide, the resulting solution. So when we bubble chlorine gas through aqueous solution of sodium bromide NaBr, chlorine is more electronegative or more reactive, so it will displace bromine from its compound, so it will form 2 NaCl plus Br2. So as the bromine is formed and aqueous bromine is formed in the solution, what will the appearance of this due to the formation of a bromine? We will say it is red brown in color. So C will be the right answer. Question 31. A solid silver halide is tested. Action of a sunlight, the solid turned gray. Why this solid turned gray? Like, because what happened is a photochemical reaction. The silver ion turned into silver atom when these halides, any of these halides are exposed to the sunlight. So the photochemical reaction will occur that any silver halide is there, fluoride, bromide, or iodide. It will form silver atom in a chlorine gas. So this silver atom is formed. This silver atom will make gray, like the color will be gray. Now, what happened if we add dilute ammonia? The solid did not dissolve. So, when we add concentrated, the solid dissolves. So remember, if we have silver fluoride or silver chloride, they are both soluble in, like dissolve in both dilute and concentrated aqueous ammonia. So it cannot be silver fluoride or silver chloride. Why? Because in both cases it dissolves. When we have silver bromide, it dissolves, like it is insoluble in dilute and it is soluble in concentrated. So in a concentrated it dissolves, but in a dilute it does not dissolve. So when we add dilute aqueous ammonia, the solid did not dissolve. But when we add concentrated, the solid dissolved. And sodium iodide is insoluble in both dilute and concentrated. So it is actually AgBr, not sodium bromide, means silver bromide is soluble in both dilute and, like, silver bromide is insoluble in dilute, but it is soluble in concentrated. Is it clear, this one? So silver halides are there. You have to learn the observations. In question 32, a flame test is carried out on a mixture of a magnesium chloride and potassium chloride. The flame colors observed was, so in case of magnesium, like magnesium, we don't, like, it is giving an energy, but that energy is not in a visible range, so there is no specific color we see. But it is giving out energy, but that energy, due to the transition of electrons, first they jump from lower to higher, and then when it returns, it gives out energy, but that energy is not in a visible range. So energy is released, but not in a visible range, so there is no specific color. But potassium is there, lilac, so one is no color, like not in a visible range, another one is lilac. So what is the observation? Observation, it will be lilac. So C will be the right answer. In question 33, the equation for a reaction of a lithium with excess water is, when lithium react with water, it will form lithium hydroxide, like soluble or aqueous lithium hydroxide, plus hydrogen gas will be released. So because alkali metals, why do we call them as alkali metals? They form hydroxide when mixed with water, and the bubbles of hydrogens are off. So this is giving us lithium oxide, that's why it is wrong. So this is lithium hydroxide, this is lithium, but this is solid lithium. The hydroxides of group 1 are soluble, so it does not give solid, it will give aqueous. That's why LiOH will be there, so D will be the right answer. Then the next one, solid sodium react with the chlorine, and the product of this reaction is added to water. So it will form a sodium chloride, and sodium chloride is a soluble salt. Like most chlorides are soluble, so sodium chloride is also except silver, mercury, and lead. So if it's a soluble salt, then what is the appearance? It will be a colorless, because group 1, 2, 3, their compounds are white solid. So whenever a white solid compound is dissolved in water, like you are adding a salt to water, what is the appearance of the water? It will be colorless, like there's no specific color you will see for the water. So it will be a colorless solution. In question 35, the solid barium hydroxide and barium sulfate are similar in there. So as I mentioned, group 1, group 2 or group 3 compound, they are white solid. So what will the appearance of barium hydroxide? White. Barium sulfate will also be white. But what about the pH of the solution? Barium hydroxide is alkaline, where barium sulfate is insoluble. So it does not dissolve. So this will have a pH higher than 7. This won't affect the pH of water. Their reaction with hydrochloric acid, this will react with hydrochloric acid, but this won't, as it is insoluble. And their solubility in water, this is insoluble, this one is soluble. So these all properties are not similar, only their colors are identical. Group 1, 2, 3, their compounds are white, solid. Transition elements, they have a specific color, compounds. Question 36. Solid magnesium carbonate and magnesium nitrate are identical in the gas release on heating. If I heat magnesium carbonate, it will give carbon dioxide. So magnesium carbonate is heated, it will give carbon dioxide. But if magnesium nitrate is heated, it will give nitrogen dioxide, like a metal oxide plus nitrogen dioxide plus oxygen. So it won't be same. The type of the oxide, the type of the gas which is released, that won't be same. Then their reaction with hydrochloric acid, when it reacts, this will form magnesium chloride plus carbon dioxide gas will be released in water, where this will form magnesium chloride plus hydrogen nitrate, like two solutions will be there. A solid product of their thermal decomposition, that's true, because if I decompose magnesium carbonate, what will the product? The product will be magnesium oxide, the solid product, carbon dioxide, and here this will decompose into metal oxide plus nitrogen dioxide plus oxygen is also there when we heat nitrates. But what is the solid product is same, metal of magnesium oxide and magnesium oxide both case. So that's why option C is the right. And their solubility, most carbonates are insoluble, so magnesium carbonate does not dissolve in water, as most of the carbonate are insoluble in water. Question 37. Which of the following equation represent the halogen displacement reaction that can occur? So always the more reactive halogen can displace the less reactive halogen from its compound. So if we try to react with iodine, as we know, like fluorine is more reactive than chlorine, chlorine is more reactive bromine, and bromine is more reactive than iodine. So down the group, the reactivity decreases. So if iodine cannot displace, so this won't happen or occur. Then bromine cannot displace chlorine from its compound because bromine is less reactive. Then chlorine cannot displace fluorine from its compound, less reactive. But chlorine can displace bromine from its compound, so this reaction will occur. That's why D will be the right answer. Then we have a silver halides, which is insoluble in water but soluble in dilute aqueous ammonia. So which one dissolve in dilute aqueous ammonia? So this one, because in dilute, this is insoluble, all are insoluble. So which one is, this is soluble in both dilute and aqueous, dilute and concentrated. So A will be the right answer. Then which of the following could not be an element in group 2? So which could not be an element of group 2? An element with an oxide which form a solution pH, and that can be group 2. An element which is with the insoluble sulfate, that can be, like example, barium sulfate is there, insoluble. An element with a chlorine which the element with a chlorine which is liquid at room temperature, like element with a chlorine, like group 2 element, if it combined with a chlorine, it will be an ionic bond, because metal and non-metal and ionic compounds are always solid at room temperature, cannot be liquid. So this is not true. And the element with carbonate which decompose on heating, so that can be group 2. So option C, why C is incorrect? Because if element with a chlorine or a chloride, it won't be liquid at room temperature, it should be solid at room temperature. Is it clear, this one? Then question 40, chlorides of group 1 element produce colored flame. When? So why the flame color is produced? That's a question. So what happened? It's when we supply the energy, electron jump to higher level. And when it bounce back or return, it release the energy. So electron become excited at a higher, that's the absorption. That's not for emitting. But excited electron move from higher. So when we have the shells, when the electron jump from lower to higher, it is absorbing energy. But when it returns back, it release, and that give a specific color and or specific energy that correspond to the flame color. Sometimes the flame, if it is the energy release in the visible range, we'll see a specific color. If the energy release in not in a visible range, then there's no specific color. Like magnesium, aluminum, there's no flame color for them. So excited electron move from higher level to lower level, that is responsible for the flame color. So B will be the right answer. An outer electron leave the atom means ionization. An electron move between negative and positive ions. That's not the case for the emitting out specific energy which correspond to flame color. Question 41. Which compound gives a green color in a flame test? So we have barium, which is apple green. Lithium is there, which is red. Potassium is there, lilac. So barium carbonate, because apple green is due to green color is due to barium. So we just have to check the metal. Question 42, which compound gives a lilac color in a flame test and does not decompose on heating? So lilac color means it should be potassium. Then which does not decompose? Potassium nitrate can decompose. If you remember, potassium nitrate can decompose into potassium nitride plus oxygen. But potassium bromide cannot decompose on heating. So potassium nitrate can decompose, but potassium bromide cannot decompose. Then 43, which of the following trends occur as we go down in group 2? So when we are going down the group 2, what is the trend? The solubility of hydroxide increases, as I mentioned, it becomes more soluble. That's true. This is true. The first ionization energy increase, that's wrong. It should decrease because the size of the atom increases, so it will become easy to remove electron. Solubility of sulfate increase, that's wrong. When we go down the groups, what happens to solubility of sulfate? It decreases. The thermal stability of carbonate, for thermal stability for all type of compound, even it's a sulfate, carbonate, nitrate, for all of them it increases as we go down the group. So that's why A is the right answer. Then the question 44, which of the following is not a true statement about hydrogen iodide? So which is not the true statement or the correct statement for hydrogen iodide? Hydrogen iodide form steamy fumes in moist air. This is true. Why? Because what happened when these halides mix in water, it will form a dense smoke. Example, if H2O is there, it combined with HCl. As a result, what will happen? It will form a dense smoke. Same thing, if water vapors are there combined with HBr, it will form a dense smoke. Water vapors are there combined with hydrogen iodide gas, all will be dense smoke. Like steamy fumes will be there. It dissolves in water to form acidic solution. That's also true because acids are proton donor. So when we add them in water, it will form hydrogen in chloride. This same HBr will form hydrogen and bromide, and HI will form hydrogen and iodide. So all of them are donating hydrogen ion. That's why they form acidic solution. Then about hydrogen iodide, it form a cream color precipitate with silver nitrate. That's wrong. It will form a yellow precipitate because white precipitate, if we have silver, hydrogen chloride or sodium like chloride ion is there, when we add silver nitrate, white precipitate. If bromide ion, it will be green, and if iodide ion is there, then it should be a yellow precipitate. So this will be yellow. It form a dense white smoke with ammonia. That's true because when ammonia react with these hydrogen halides, it will form the salt ammonium chloride or ammonium bromide, which is a dense white smoke. So ammonium chloride, ammonium bromide, or ammonium iodide result in a dense white smoke. So these are the MCQs related to